12 here at Roasted College in Rukwani on 910 to Skuma. Okay, now today I want to take you through financial mathematics so that we are ready for our coming exams ahead. Now we have the important terms which we need to understand first before we continue, like inflation. That is the rate at which prices increase over time is called inflation, and it is usually a compound interest. Okay, and then another one is called the consumer price index, that is CPI. That means the average prices of a basket of goods which keeps on increasing every year. Then we have exchange rates. That means the value of one currency for the purpose of conversion to another, like from dollars to rands, from rands to pounds, and so on. Then we have what we call as population growth. That is a change of population size over time. This one usually occurs as a compound interest. And then we have what we call as hire purchase. That is a short-term loan, deposit payable, calculated using simple interest. Okay. And then another one is called reducing balance loan. That is, in this case, interest is paid on the reducing balance. The lower the balance, the less you have to pay. And then also we have what we call as nominal interest rate. That is the quoted period and the compounded period. That is different. For example, 15% per annum compounded monthly. You see, they're saying per annum but compounded monthly, so it means that the quoted period and the compounded period, they are different. And then we have what we call as the effective interest rate. In that case, the quoted period and the compound period is equal. For example, 0.75% per month compounded monthly. And we're going to see how to convert from nominal to effective interest rates in our examples shortly. And then note that when we are using compound interest, we have the following compound periods, that is annually, which means once per year, then semi-annually, which means twice per year. If we say compounded quarterly, it means 4 times in 1 year. If we say compounded monthly, it means 12 times in 1 year. It can even be daily. That means 365 days, 365 times in 1 year, except for the leap years. Okay. All right. Now, after knowing those terms, let us start with the simple interest. Okay. We are starting simple. Don't worry. Good things are coming ahead. Okay. All right. Now, with the simple interest, the formula is A equals to P into 1 plus I times N, or you can use A equals to P into 1 plus R over 100 times N. That is simple interest, whereby our A means the accumulated amount and then P is the original amount. Okay. Then N is the number of periods, and then R is the interest rate as a percentage. And then I, it stands for the interest rate out of 100. Okay, and then together with the compound interest, the formula is A equals to P into 1 plus I power N, or you can write it as A equals to P into 1 plus R over 100 power N. We still have the same definitions here for A, P, N, R, and I. Okay, let's look at an example here. I have an example here. It says, determine the difference in the accumulated amounts when investing your savings of 15,000 rands for 4 years at 2 different banks. Both offer 6.5%. However, one offers simple interest and the other compound interest. Now, with the simple interest, the formula says A equals to P into 1 plus I times N. So because they gave us the 6.5%, so our I is going to be this one divided by 100, which gives us what? 0.065. So we're going to have our amount accumulated in 4 years to be 15,000 times open brackets 1 plus 0.065 times 4, which gives us 18,900 rands. That's if we use what? The simple interest offer. However, if we use compound interest offer, we're going to have power n here, so it's going to be 15,000 into 1 plus the same rate at 0.065 to the power of 4, which gives us 19,296.99. As you can see, the one for compound interest is higher than the one for the simple interest. In that case, if we are to show this graphically, if this is our money here, now the compound interest, it moves exponentially. You see it's going up like a parabola. It moves exponentially, it increases, okay? And then with the simple interest, it is a straight line with the same gradient. So this is simple interest, this one is for the compound interest over a period of time. In other words, if you have the same rate, I advise you to choose a compound interest offer because it's gonna give you more money at the end of the compounding period. Now another term here is about hire purchase. Now hire purchase, you buy a washing machine of 4,000 by signing a 2-year hire purchase agreement. You pay 800 rands deposit, calculate the total amount you will repay if the interest rate is 12%. Okay, so now in that case, how much are you going to pay if the rate is 12%? Let's check it out. We are saying that you buy the washing machine, okay? You buy a washing machine at 4,000 rands, okay? And then by signing a 2-year hire purchase agreement, and then you pay 800 rands deposit. That's your deposit paid, okay? Now the first question says calculate the total amount you will repay if the interest rate is 12%. Okay, and then also your monthly installments. Now don't forget that the machine was costing how much? It was costing 4,000 rands, but then you had some deposit which was 800. So if you pay it off, we're going to first subtract 4,000 minus what? Minus 800. So because you don't have the balance, which is 3.2, they're going to charge you some small interest using simple interest, then to have the total amount to be paid if the interest rate is what? 12%. So this is what we do here. Okay, so now don't forget that our deposit was 800 rands. So that 800 from the 4,000, you have the 3.2. Now this money is for the loan. Because of that, it must accumulate some interest. That's why we're using the simple interest formula here. Meaning that we are going to have our P at 3.2, and then they gave us the rate here. Then after 2 years, it's going to accumulate to what? To 3,968. Okay, so this is the amount which you're going to pay besides the deposit. Are we together? You see, instead of paying 3,200, if you had the cash, you're going to pay 3,968. Okay. Let's check the other part of the question. What does it want us to do? They say your monthly installment. Now, because you are paying it in 2 years, it means you're going to divide this money by the month in 2 years. So this money in 2 years equal in payments is going to be the 3,968 divided by 24, which gives us what? 165 rands and 33 cents every month end for 2 years. Then you get your what? You get your washing machine after the 2 years. Are we together? To be completely paid up. Yeah, that was to do with hire purchase. You've seen we have been using simple interest. Okay, let's look at something else now. Now, apart from hire purchase, let us look at something else here. In this case, let us look at what we call as okay. Now we have seen that with compound interest, it moves up. Simple, it is a straight line, that's a gradient. Okay, now let us talk about population growth. Now the population in the future is the same as the population presently, then times the compounding interest rate. Okay, so in this particular case, we're using this formula here. So note, if in your test they talk about increase in population, please don't use simple interest, but use what? Compound interest. Okay, so this is future population size, and then present population size, and then I is the average population, and then N is the number of years. So people increase so much, they increase at a compounding interest rate. Okay, for example, the population of lions is 2,567 in 2015. If the growth rate is 1.34%, calculate the number of lions in 2020. So now from 2015 to 2020, we need to get how many years are those? That is 2020 minus 2015 gives us 5 years. So to get our number of lions in 2020, we're going to use the 5 here as our N, and using the beginning number of lions, that was our P, it gives us what? It gives us 2,743 lions. Now, because these are lions, it must be an integer. We don't expect decimals here. We don't expect what? Decimals here. Hope we are together. Let us proceed. That was population growth. And then another one here, let's look at something else here. Now, we know when we're using compound interest, please take note of the following. Take note of the following here. If we say we are compounding annually, we say it means we are compounding it once, okay? Once in a year. But if the investment is done quarterly, let us see this example here. Example says, calculate the future value of your investment after 3 years at an interest rate of 15% per annum compounded as follows. Okay, let us look at different compound periods here. Now, don't forget that what we are dealing with, the question says, calculate the future value of your investment after 3 years at an interest rate of what? 15% per annum. It can be compounded annually. In that case, we're going to have the 15,000, okay? 15,000 into 1 plus I power n. Now, because it's done once a year, it's going to be done 3 times. That means power 3. Okay, so it's going to give us how much? It's going to give us this money, which is 22,813.13. Now, if it can be compounded semi-annually, now in that case, for the 3 years, it's going to be compounded how many times? That means it's going to be 3 times, because it is twice every year, it's going to be 3 times 2, it gives us 6 years here. So we're going to now divide I by 2 and multiply n by what? By 2. Because our n was 3 years, it's going to be 3 times 2, which is 6 here. That's why I've got power 6 here. So it's going to be how much? 23,149.52 instead of the previous 22,813. However, it can be compounded quarterly as well. Now, if we compound quarterly, note something here that we divide I by 4 and multiply n by 4. Our n was 3 years. So what is 3 times 4? It is 12. That's why it is 12 here. It gives us 23,331.81. And then apart from that, it can also be compounded monthly. So monthly, which means 12 times in 1 year, because we're talking about 3 years, we're going to have yes, I divided by 12, and then 3 times 12, which is 36. Okay, this is what? 3 times 12, which gives us what? 36 here. So it gives us 23,495.16. Okay. Now, I think you can see that the more number of compounding periods, the more the money. This is the biggest money. This is 23,495, so it's 23,331. So take note of that. So that's why it's that businesses, they deposit money every day because they want to get a bigger amount. Okay, now as compounding periods increases during the year, so the accumulated amount increases, as we have seen. Another example here, it says, if 13,865 is received after 6 years of being invested and the interest rate was 16% compounded annually, what was the original amount we invested. So here, this is now the final amount here given to us. Okay, so they've given us the final amount, which is 13,865, and then they have said after 6 years, and using this rate, and they're saying compounded annually. Okay, so they say what was the original amount. Now original amount, we said from the start, that is the P. Okay, so our formula says that amount A equals to P into 1 plus I power n. Because they gave us the final amount, which is 13,865, we put it here. We're looking for this P into 1 plus 0.16 power 6, yes. So simplify here in brackets, you get 2.44p. Then decide we divide by what? By 2.44, which gives us actually the final answer for P, that is 5690.78. I hope we are together. Now this money, the 5,690.78 was the principal amount invested. However, we can use a better formula to get the answer direct. You see, the formula is like A equals to P into 1 plus I power n. That's if you're looking for A. However, if I'm looking for P, I divide by this one here, this side, and then when it comes up, the n becomes a negative power. That's why it's going to be P equals to amount into 1 plus I power negative n to find my P. Hope we are still together, guys. Okay, let's continue. Yes, let's continue to the next page. Now yeah, that was the grade 10 work and some part of grade 11. Let's continue now because we have to go quite far. Now next page here we have sometimes in financial mathematics they can want us to use what we call, we can have different withdrawals, and then we can deposit and withdraw. Even you can have changing interest rates. So we still have the nominal and effective interest rates. Let us check out other examples here. So if you check here now, if you check this now here we're looking at what happens when we have the changing interest rates, and then also depreciation, and then also going to look at the nominal versus effective interest rates. That's compounding interest. Okay, now the annual effective rate is equivalent to the nominal rate per annum compounded monthly because it must produce the same amount to be accumulated. So this formula which is, that is 1 plus I effective equals to 1 plus I nominal over n power n, is what we use when we are converting from nominal to effective interest rate. Okay, now this is I effective rate, that's annual, and then nominal rate is I nom, then n is the number of compoundings per year. N is what? Number of compoundings per year. If they say monthly, it means divide here by 12 and the power 12. If they compound quarterly, divide by 4 and the power 4. If they compound semi-annually, divide by 2 and the power by 2. Hope we are together. Example here. They say that convert a nominal rate of 18% per annum compounded monthly to an annual effective rate. So you see, this is 18% per annum compounded monthly to an annual what? An annual effective rate. So if you check here, this is 18% per annum, but they're saying compounded monthly. So you see, so we need an effective rate. So we use the same formula there which I showed you up, that we're going to say 1 plus I effective equals to open brackets 1 plus this is 0.18 divided by 12 then power 12, because they're saying compounded monthly. That's why we divide by 12 and the power 12 here. So on no calculator, this one can be simplified and it gives us minus 1 gives us 0.196. So multiply by 100 to get our rate. It gives us our effective to be 19.6%. Hope we are together. Let us proceed. Now here they say that you invested 25,000 at 14% per annum compounded monthly for a period of 12 months. Use the annual effective rate to show that the same accumulated amount will be obtained as when using the nominal rate. I repeat, you invest 25,000 rands at 14% per annum compounded monthly for a period of 12 months. Use the annual effective rate to show that the same accumulated amount will be obtained when using the nominal rate. Okay, now first let us get our rate, which is going to be monthly. So this is the formula here. We divide by 12 and power 12 here. So this one, then if you say minus this one, it gives us 0.1493. So percentage gives us what? 14.93. So what does the formula say? A equals to P into 1 plus I power n. So this is 25,000. Then into 1 plus this 14% over 12 power 12. It gives us what? It gives us 28,733.55. Okay. Let us now check what if we didn't do it monthly, and we did it once a year. Let us check it out. So it's going to be A equals to P into 1 plus I power n. So this is 1 plus, our I is still 0.1493 power what? Power 1. It gives us what? It gives us 28,733.55. So you see, we get the same answer. We get the same what? The same answer here. And let us look at something else now. Now, sometimes we can have in financial mathematics, whereby we have to do what? To change the rates, the interest rates. Please pay attention here. Now, if the interest rate changes after a set period of time, what must you do? What must you do? Okay. Now, in this case, this is what we do. This is what we do. First of all, you determine the accumulated amount after the first period. You do what? You determine the amount after the first period, that's before the rate was changed. And then when you are done with that, you set the accumulated amount as the initial amount for the second period. Okay, you do what? You set the amount accumulated as the initial amount for the second period. Then when you are done, now you can determine the amount accumulated after the second period. Now you can do what? You can determine the amount after the second period. Okay, so that's what we are saying here. So I think we have an example here. Seriously? Yes, let's check it out. Now the question here says that 100,000 rands is vested for 6 years at an interest rate of what? 16% per annum compounded quarterly. Thereafter, the accumulated amount is reinvested for 5 years at an interest rate of 14% compounded semi-annually. Calculate the value of the investment at the end of this period. Okay, let us check it properly. Now the question says that 100,000 is done what? Is invested for 6 years at an interest rate of 16% per annum compounded. So this is the first period, 6 years at which rate? At a rate of 16% per annum compounded quarterly. Okay, so you first deal with that one there. When you are done, they say thereafter the accumulated amount is reinvested for 5 years at 14% compounded semi-annually. So now in that case, the one for 5 years is to be done later. So after getting your answer here, you proceed and make that answer to be your P, and then you do it now for 5 years. Okay, at what? At 14% compounded semi-annually. Then later you get your final answer for the investment, that value of the investment. Let us check it properly. Now this is the formula here. Now for the first 6 years, because we are compounding quarterly, we are going to say I divided by 4, then power 6 times 4. What is 6 times 4? It is 24. Okay, so it gives us what? It gives us 256,330.42. Now this is the first 6 years altogether. After getting this first answer here, then you proceed and use it for the next 5 years. Hope we are together. You do what? Proceed and use it for the next 5 years using the same formula. So this answer is what we're going to put your P now. And now this time you're going to compound semi-annually at 14%. So because we are compounding semi-annually, we divide I by 2 and multiply the 5 years by 2, which gives us 10 here. So you see our final answer is going to be what? 504,000, then 239.91. Hope we are together. This is our final answer here. This is our final answer here. I hope we are together. If we are not together, please pause the video and watch it again. No problem. Okay. Okay, so another example to make ourselves very clear. Example says that 30,000 was left to you in a savings account. The interest rate for the first 4 years is 12% per annum, compounded semi-annually. Thereafter, the rates change to 18% per annum, compounded monthly, and you leave the money for another 3 years. What is the value? What is the future value? What is what? What is the future value? What is the future value? So what do we do in that case? What do we do in that case? Talk to me now. The question says that 30,000 was left to you in a savings account. The interest rate for the first 4 years is 12% per annum, compounded semi-annually. Thereafter, the rates change to 18% per annum, compounded monthly, and you leave the money for another 3 years. What's the future value of the investment after the saving period, the 2 savings period? Okay. Now, like we said before, what do you do first? You first deal with the 30,000 and get your answer using the first 4 years. Using the first 4 years at 12% per annum, compounded monthly, compounded semi-annually. All together, this one is going to be your P into 1 plus I. That means 1 plus 12%. Divided by 2, power 4 times 2 altogether. After getting your answer, then now you proceed to use that answer. Thereafter, using 18%, okay, per annum, compounded monthly, okay, altogether. That means we're gonna say this answer here, open brackets, 1 plus 18%, okay, divided by 12. Power 3 times 12, because they're saying for the next 3 years, okay? And then that will give you the final answer. Let's check it out properly. Now, in the first 4 years, and because we are compounding semi-annually, that's why I divide I by 12 and multiply 4 by 2. I by 2 and multiply the 4 years by 2 to give us 8 here, which gives this answer here. And then after getting this answer, we said you carry it forward, bring it, put it here. Now you compound monthly. That's why dividing by 12, then power 3 times 12, which is 36, which gives us this final answer here. Now all these steps can be done in one single step alternatively, like this. Okay, watch this properly, please. Now for the first period of which was for semi-annually, it begins from here up to here, right? Up to here, and then because we are compounding semi-annually for the first 4 years, we said you multiply 4 by 2, which gives you this 8, and then divide I by what? By 2. That's why there is a divided by 2 here. Now the answer which you get here, you make it the P, then multiply by open brackets into 1 plus I. Now because now they're compounding monthly, that's why we divide by 12 here. They're saying for the next 3 years, that's why we multiply, we make it to power 3 times 12, which is 36. So now this single step gives us the final answer. Okay. Now, if you compare the two answers, they are the same. So this answer here is 81,723.26, the same as what you see here. So, which means both methods are correct, and both methods carry the same number of marks. Hope we are together. Let us proceed. Let us proceed. Let us look at what we call as depreciation. Now, depreciation is divided into two, and we have some terms to understand here. Now, depreciation, or which you call decay, is the loss or decrease of value at a specified rate over time. The depreciation means loss of value over time. What about book value? The value of equipment at a given time after depreciation. And then the scrap value is the book value of an equipment at the end of its useful life. Okay. In this case, A is the book or scrap value, and then P the present value, I is the depreciation rate, and N is the what? Time period. Okay, so we have got two types, like we said. We have what we call as linear depreciation and a compound depreciation. Now, linear depreciation is also known as straight line depreciation. So in your test, they will tell you what they want. They can say, calculate the answer using straight line depreciation. It means you must use this formula here. However, if they say calculate your answer using a reducing balance, okay, in this case it means you have to do something else now. Okay, in that case you have to use what you see here. So this is also called what? Compound depreciation, also known as what? Reducing balance. Okay, so this must be the formula then. That's amount A equals to P into 1 minus I power N. This is reducing balance depreciation. Okay, let us proceed. Now, how are they different? This one is straight line depreciation. You see it's the constant gradient for a straight line. Actually, it goes up to 0. Are we together? And then this one which has got reducing balance, it decreases faster but does not go to 0. As you can see, it becomes constant over a period of over a number of periods. Okay, this is the value of the asset here. Let's look at an example here to see how we explain it properly. Example says that my new car to the value of 200,000 rands, okay, depreciates at a rate of what? 9% per annum. Okay, per annum. They say, what would the value of my car be after 6 years? Compare linear depreciation, reducing balance depreciation. So the initial value of the car is what? It is 200,000 rands. At which rate let's depreciate? 9%. So we want to compare linear depreciation and reducing balance depreciation. Okay. Now linear, it is P into 1 minus I times N. What about reducing? P into 1 minus I power N. Okay. The same initial amount, but here it is linear, here it is to the power. Okay. So here we get 92,000. What about with reducing balance? We get how much? We get 113,573.85 rands. Okay, so it's the difference. The difference that in here we get a bigger amount. What about here? We get a less amount. So with linear depreciation, we get a less amount. What about reducing the balance depreciation? We get a larger value here. Another example to make it much clearer, we are saying that the value of a piece of equipment depreciates from 15,000 to 5,000 in 4 years. Okay, what's the rate of depreciation calculated on the what? On the straight line method or reducing balance method? I repeat, the question says that the value of a piece of equipment depreciates from 15,000 to 5,000 in 4 years. What is the rate of depreciation calculated on the what? Straight line method and then reducing balance method. Okay, So now if something depreciates, it means it gets from a bigger value to a less value. So in this formula here, this A is always the smaller value, then it is the bigger value, okay? So this is straight line, okay, looking for the interest rate. That's why there is X here now, then times 4. Then I open brackets here. 4 times 15 gives us this 60,000, and then this one comes, this side becomes a minus. So 5,000 minus 15 gives us negative 10,000, divided by negative 60,000 gives us positive 0.1667. So multiply by 100 to get our rate gives us what? 16.67%. However, on the reducing balance depreciation, we have A equals to P into 1 minus I power n, 5,000 the less value, from 15,000 again, divided by 15, which gives you 1 over 3 here. And then because you're looking for I, so you're going to find the fourth root. Find the fourth root, which gives here, this one here, and then after getting that fourth root, this one becomes a minus. That's why it's minus 1 here. So this is minus x this side, so divide by negative 1 to make it positive. Now to change from I to R at the rate, multiply by what? By 100, which gives 24%. Hope we are together. If we are not, what did we say? Pause the video and watch it again. And watch it again. Let us proceed. Let's proceed. Now that was so interesting. That was so interesting. Sometimes in financial mathematics we can have additional payments or withdrawals, and in that case we use timelines to show our things properly, okay, to see what is happening to our account, our investment, okay. We use what? Timelines, okay. So we are saying here that additional payments or withdrawals, so we use timelines to assist in visualizing and keeping track of different rates and payments. So what do? You set up each section with information about the number of terms, compound periods, and interest rates, okay. I have an example here. For example here, what do we say? You deposit 5,000 into a savings account, and 4 years later you add 4.5. The interest for the first 3 years was 11% compounded quarterly. Then it changed to what? To 12.5% compounded monthly. Calculate the savings at the end of the 6th year. I repeat, the question says that you deposit 5,000 rands into a savings account, and 4 years later, what do? You add 4,500. The interest for the first 3 years was 11% compounded quarterly, and then it changed to 12.25% compounded monthly. The question says calculate the savings at the end of the 6th year. So in this case, what we do here. Now, don't forget that for the first 3 years, our interest rate was 11% compounded quarterly. That's divided by 4 here. And because we are compounding quarterly in the 3 years, we're going to have 3 times 4, which gives us 12 for the compounding period. And then in the next 1 year, because they said it's going to be now compounded monthly, you see here, compounded what? Monthly. We're going to divide the I by 12, and because this is just 1 year, it's going to be what? It's going to be 1 times 12, which gives us 12 here. And then what happened? You later added 4.5. Now this one means we are adding to the account. This money has been added here, and then that's by the 4th year. Now if we add it here by the end of the 4th year, it means you're going to spend how many years to the 6th year? You're going to spend 2 years. But don't forget that our I is what? It is 12.5% compounded monthly. That's why I divided by 12 here. And because it's only 2 years, it means it's going to be 2 times 12, which is 24 here. So in that particular case, what do we have? Once again, we said you deposit 5,000 into a savings account, and 4 years later you add 4.5. The interest for the first 3 years was 11% compounded quarterly. Then it changed to 12.5% compounded monthly. Calculate the savings at the end of the 6th year. Now, at the end of the 6th year, what do you do? Pay attention here. Now, at the end of the first 3 years, I'm going to have P into 1 plus I power n. That means the 5,000 initially into 1 plus 0.1 divided by 4 power 12. Why 12? Because it is 4 times the 3 years to give me 12. So I get this money here. That is 6923.92. Now, in the next 1 year, before I add the 4.5, it was compounded monthly. And because it's only that 1 year, it means I'm going to have I divided by 12, then power 1 times 12, which is 12 here. Don't forget that that's when they added the other money of what? Of 4.5, okay? So here this is the addition. So the answer which I get here using this money within the next year is going to be this money plus the 4.5, which gives me what? 12,340.76. Okay, now in the next 2 years we are compounding monthly, don't forget. So for that matter, I'm going to divide I by what? By 12, and because it's next 2 years, what is 12 times 2? 24. So this answer which I have here within the next 2 years is going to yield this money, which is 15,825.37. Hope we are together. So whenever they say that in the savings account, if they deposit, we add, okay, and then if they withdraw, we subtract. That's the note which you see here, that if withdrawals are made from the savings account, you do what? Then use subtraction here instead of addition. Okay, all right. And now this could still be done in a single step. Let me explain it properly. Please pay attention here. Now, I was having 5,000, okay? For the first 3 years, the interest rate was done quarterly, altogether. And then, because it was for the first 3 years, that means I'm being done quarterly. I divide I by 4. And then I do what? I power 3 times 4, which is 12 here, altogether. And then within the next 1 year, it was changed to monthly, altogether by 12.5%. So it's going to be this one here divided by 12, because it's within 1 year. That is what? That is power 1 times 12, which is 12 here. But because I am depositing another 4.5, it means that's why there's addition here, 4.5. So the whole of this one here now together makes that 4th year altogether. And then within the next 2 years, where we are compounding monthly, we are dividing I by 12 and then power 2 times 12, which gives me 24. So surely, if I punch in everything here, I still get 15,825.37. Hope we are together. If you're not together, please feel free, pause the video and watch it again. Now, sometimes you can have withdrawals as well. Let's check it here. Another example. They say here that you take out a loan to buy a new iPad. You make an additional payment of 5,000, okay, 4 years after taking out the loan. 2 years later, you repay the final amount of 6,000. During the first 4 years of the loan, the interest rate was 14% per annum, compounded semi-annually. For the last 2 years, the rate changed to 11% per annum, compounded quarterly. They say, how much did you initially borrow? I repeat, you take out a loan to buy an iPad. After buying the iPad, what happens? You make an additional payment of 5,000. Okay, that's after 2 years. And then 4 years after taking out the loan, okay? Let's check properly. We're saying that you do what? You take out a loan to buy a new iPad. You make an additional payment of 5,000 4 years after taking out the loan. Then 2 years later, after the 4 years, 2 years later, you repay the final amount of how much? Of 6,000. So that's the final amount which has been paid of 6,000. Okay. Now they say during the first 4 years of the loan, the interest rate is 14% per annum, compounded semi-annually. So during the first what? During the first 4 years, this is 14% per annum, compounded semi-annually. Then they say for the last 2 years, the rate changed to 11% per annum, compounded quarterly. So for the last 2 years, the rate was how much now? It was 11% per annum, compounded quarterly. The question says, how much did you initially borrow? So initially, meaning you're looking for the P. Now the A is the 6,000 in that case. That's what you have here. Okay, let's check it out now properly. Now pay attention please. Now at the beginning here, I don't know how much I had, but 4 years later, I paid 5,000. Altogether, I paid how much? 5,000. And the rate was being done semi-annually, compounded semi-annually. That's why it is I divided by 2. And that was after the what? After the 4 years. That is 4 times 2, which is 8 here. Okay. And then these 4 years later, I paid 5,000, right? Which means that now the 5,000 is going to be helping me to pay off the money, right? Now the remaining 2 years, the rate changed to what? To 11% compounded quarterly. That's why it is divided by 4. Then because it is 2 years, then times 4 giving me 8 here. Then then at last I pay how much? I pay the 6,000. So I have to work backwards. So working backwards, I need to get the value of the loan at Y4 here. Now P equals to A into 1 plus I power n. Don't forget that this formula for the amount, it can be A equals to P into 1 plus I power n if I'm looking for A, and it can be P equals to A into 1 plus I power negative n if I'm looking for P. So because I'm interested in the P, that's why my n is in negative power here. So starting from here, I'm going to have P equals to 6,000 open brackets 1 plus 0.11 over 4 power negative 8. The 8 is on here, which you see here. So it means I have my 4,008 29,44. Are we together? Now that means that the loan amount at the end of the end of 4th year, before the payment of 5,000 was made, was this one here. Did you hear that? That means that the loan amount at the end of year 4, before the payment of 5,000 was made, it was how much? It was 9,829,44. Then somebody can say, how do you get it? I simply add 5,000 plus this, which gives me what? 9,829,44. Now from there, again you work backwards to determine the initial amount borrowed. Okay, so the loan amount at Y0. So P equals to A into 1 plus I power negative n. So now this money which is here, I'm going to put it here and put negative 8 here, because remember it was what? It was compounded semi-annually for the first 4 years. That's why it was 4 times 2, which is power negative 8 here. So it gives me my P as what? As 5,720,82. Hope we are together. Now I can combine all the steps above in a single calculation by using P equals to 6,000 into open brackets, this one here, after the first 4 years where I paid another extra 5,000, then multiplied by the remaining 2 years compounding semi-annually. Okay, then power negative 8, which gives me the same money, which is 5,720,82. Are we together? If we are not, please pause the video and watch it again. Now we have another question to try out here together. This was done 2020, Eastern Cape, November. It says calculate the effective interest rate per annum if an investment of 9,5 5% interest per annum compounded monthly. What does the question want? They say calculate what? The effective interest rate per annum if the investment earns what? 9.5% interest per annum compounded monthly. So here they're compounding monthly, and I want to get my what? I want to calculate my effective interest rate. Okay, remember the formula? We said 1 plus I effective equals open brackets into 1 plus I nominal over n power n. Okay, so here we are using 9.5% compounded monthly. Let's check it out now. Okay, so we said that what does the formula say? We said that it is 1, okay, plus I effective, okay, I effective equals to open brackets into 1 plus I nominal, okay, divide by n, everything to the power n. Okay, so because I'm looking for I effective, I'm gonna bring this on this side, let's subtract it. So it means I'm going to have open brackets, okay, that is 1 plus, now our I nominal was 9.5%, so we say 9.5, okay, percent. Because they're compounding monthly, I divide by what? By 12, okay. Then we say the power n is also still 12, and then minus 1, okay. If you've got a calculator, please get me the answer. In that case, with my calculator here, it gives me what? It gives me what? After subtracting 1, it gives me I effective as 0.0, right? 247 here. Then 584, okay. Now because I'm looking for the percentage rate, so I multiply this one by what? By 100. It's going to be 100 multiplied by what? By this 0.009, I can set to 5, okay, which gives me what? Which gives me 9.92%. 9.92%, okay. So that's my answer there. Hope we are together. Okay, let's check the next question. So that is our effective interest rate, okay, if we compound monthly. Now next they say here that what must we do? What must we do? Okay, they say now that the value of a house increased to 764,050,60 over a period of 5 years due to inflation. The price of the house increased at a rate of what? 5% per annum compounded annually. Calculate the original price of the house. Okay, so the value of the house increased to this one here over 5 years due to inflation. Now the price of the house increased at a rate of what? 5% per annum compounded annually. So calculate the original price of the house. So what did we say? We said that our formula said that amount equals to P into 1 plus I power n. What about if I'm looking for the what? I'm looking for the P. We said that in that case, our P, okay, our P in that case could be what? It can be P equals, open brackets, A into 1 plus I the power negative n. So in this particular case, If you check my A is what? It is the 764, 764, 764, and then what? 050, 050, comma 60, ne? Comma 60, open brackets, into 1 plus I. What is our rate here? 6%, ne? That means 5%. That means 5 out of 100. Okay, and then because it's compounded annually, ne? So power how many years? Power 5, but negative 5, ne? Okay, power negative 5 here. So which answer do you get here? Anybody with the calculator? You can help us here. So what do we get? With the calc here, me, I'm getting 598, 598, 653, 653, okay, comma 64. So this was the original money for the house. Okay, because of inflation it has increased the price to give to what? To 764050. Hope we are still together, guys. Okay, next question here. It says that CAMV invested 28,000 into a savings account that pays interest rate at what? 7.5% per annum compounded monthly for the first 4 years and 11% per annum compounded quarterly. Thereafter, at the end of the 4th year, he withdrew 7,300. Calculate his balance at the end of the 7th year after his investment. Okay, so how much was invested? 28,000 into savings account that pays how much? Pays 7.5% per annum compounded monthly for the first 4 years, and then 11% per annum compounded quarterly. Thereafter, at the end of the 4th year, they say he withdrew 7,300. Calculate his balance at the end of the 7th year. Okay, so here we need a timeline. We need what? We need a timeline here. So let's like this. So in that case, because we need a timeline, let's get some space here. Okay, so how much was invested? It is 28,000. You can see that. So it means that if I come back here and I first get my line here, it's all there from here. Okay, so initially we have that 28,000. 20 what? 28,000 is what we have there initially. 28,000. Okay, then they say that pays 7.5% per annum compounded monthly for the first 4 years. So this is the in beginning time. So after 4 years here, after 4 years here, what happened? That's after 4 years. Why 4? After 4 years, they said that what happened? Withdrew 7,300. So it is now minus 7,300 and 0. Okay, so they're saying that after that, what happened at the end of the 4th year? Okay, per annum compounded quarterly. Now the first compounding was done in monthly, so this one here, our I is gonna be what? Monthly, because so we divide I by what? We divide I by 12. How many years? They said 4 years, so what is 4 times 12? 4 times 12, it gives us what? It gives us 48, right? Yes, 48 here. Okay, and then for the remaining 3 years after the withdrawal here, remember that here we are dividing I by 12, because we are compounding monthly. Here they're compounding how? They're compounding quarterly. So I'm going to divide now at my year 7. within this remaining 3 years, I divide I by what? Because I'm compounding quarter, I divide I by 4. So remaining 3 years means my n is going to be what? It's going to be n equals to 4 multiplied by 3, which gives me what? Which gives me 12. So now if I come to get my final amount here, it's going to be amount A, okay, equals to, what's my first part? It is 28,000, okay, 28,000, okay, then open brackets. Okay, do it this side, I beg your pardon, 28,000, and forget, it is 28,000, okay, come here, decide that our amount, yes, our amount is amount equals to what? 28,000, 28,000, open brackets, then into 1 plus what? 1. Now we're dividing I by what? By 12, because it was done monthly. That means 7.5%, 7.5%, okay. Divided by what? Divided by 12, okay. Divided by 12. Because it was done for the first 4 years, so now be 4 times 12, power 4 times 12 here. 4 times 12, okay. When I'm done with that, now because there's a change in the rate, I multiply by what? Open another bracket here. That's going to be 1 plus, it was 11% quarterly, that means plus 11%, 11%, so divided by 4 for the next 3 years, that's why it's going to be power what? Power 3 times 4, 3 times 4, okay. Then there was a withdrawal of 7300, so minus 7300. That money withdrawn was within the last 3 years, okay. So open brackets again here, we say 1 plus, it is still done for compound quarterly, that means 11%, 11% divided by what? Divided by 4, and then because it's for 3 years, it's going to be power what? Power 3 times 4 again here, okay. Now on your calculator, you put in everything as you see it here and get your final answer. What's your final answer there, guys? Anybody with a calculator? Mine here, it is 4218. It is 4218, 4218,59. 4218,181 is 4218,59. So that's the value of the investment after what? After the 7 years. Hope we are together. Let us proceed. Next they say here that assuming that at the end of 7 years his balance is 4218,159, come V wants his investment to grow to 80,000 rands in another 5 years time. How much must he deposit into the account immediately to achieve this goal if the bank offers 8% per annum interest compounded monthly? Write your answer to the what? Nearest rand. Okay, so in this particular case the question says, assuming that at the end of the 7 years, the money which we got was 4218,159. This guy wants to invest it to grow the money to what? To 80,000 rands within the next 5 years. They say how much must he deposit into the account immediately to achieve this goal if the bank gives him what? 8% per annum interest, compounded monthly. Okay, let's check it out in that case. Now, because we're looking for the money to be invested, we're looking for P. So let's check. We're looking for P now. So in this particular case, we want to get 80,000 using this money here. Okay, let us find out. We want to get 80,000 using that money there. So it means that we're going to do let's work it out here. Let's work it out here. Now, don't forget that in this particular case, the formula, we know it says that amount A equals to what? Equals to P, open brackets, into 1 plus I to the power n. But if I'm looking for P equals to A, open brackets, 1 plus I, now this time to the power negative n. Okay, if you're looking for P. So I forgot A here. Yes, I forgot A here. Beg your pardon. There must be A there. So I'm saying P equals to A, open bracket, into 1 plus I power negative n. So it's going to be, now I want to get what? The 80,000. So I'm going to put 80,000 here. 80,000 all together, open brackets, plus I. They said 8%, that's what the bank gives, and it is compounded how? They said compounded monthly, so divided by 12 to the power negative. They said within the next 5 years, negative 5 times 12. 5 times 12. So anybody with a calculator, please get me the answer. Here I get 696,84. Yes, 84. That's what I get here. I get 53696,84. That's what he must invest to double his money, like to get 80,000. Okay. Now, please, guys, finish up these questions here, complete them up, and see you again in my next video. Okay. This one as well. Try it out. Again, my name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences grade 11 here in Pulukwane State College. Catch you.